2018, paper 2, question 5. So this question is based heavily around the line and the circle. So we're given two lines M and N, and we're told that they are parallel to each other. And the very first thing that we're asked to do here is to verify that A is on M. So that's really easy, because all we have to do is take our point A, and we're going to take the line M. And if a point is on a line, that means it satisfies it. So that means that if I sub in for X and I sub in for Y, the left-hand side should equal the right-hand side. So we have 2 times minus 2 plus 3 times 1 plus 1. And I want to see, is that equal to 0? So of course we end up with minus 4 plus 3 plus 1 is equal to 0. So that's true, because minus 4 plus 4 is 0. And therefore we say, therefore, A is on the line M. So again, always making sure you're concluding. So it was 10 marks going for that video. It was very generous in terms of a very easy question. So in B, we're asked to find the coordinates of B. So that means we're looking for both X and Y. And B is the point on the line N, which is the closest to A. So that implies that it must be the line perpendicular to the line M. So in other words, the shortest distance between any two parallel lines will always be that perpendicular distance. So therefore, that implies that if I want to find the point B, I need to first of all know what this line here perpendicular to M is, because then I can find the point of intersection of that perpendicular line and the line N. So we know what, so say A to B is going to be perpendicular to M. Okay, so we know what the line M is. It's 2x plus 3y plus 1 equals 0. So that means I can work out what the slope of the line M is and then get the perpendicular slope. So A is 2, B is 3, C is 1. So you can either get your slope in the form of y equals mx plus c, or m is equal to minus a over b. So therefore our slope for the line M is minus 2 over 3. Or just use your y equals mx plus c, making sure the coefficient of y is 1 if you're doing that though. And therefore I can say my perpendicular slope of the line AB, well, all I have to do is turn it upside down and change the sign, so it's going to be 3 over 2. So now I know the slope of the line AB, and I already know what A is, and I'm verified in part A that A is on M. So now if I want the equation of the line AB, well, I'm just going to use y minus y1 equals m times x minus x1, which is page 18 in your maths tables. And making sure we're subbing in the correct slope. So our slope is the perpendicular slope, and the point that we're subbing in is the point A, which we said was minus 2, 1. So we're subbing in for x and y there. So we have y minus y1 equals m times x minus x1. So again, making sure you're using brackets when subbing in. And therefore we end up multiplying across by 2 there. So that's 2y minus 2 is equal to 3 times x plus 2. So 2y minus 2 equals 3x plus 6. So bringing everything to one side, we have 3x minus 2y plus 8 equals 0. So this is the line in red here in my diagram. It's the perpendicular line. So now what I need to do is find the point of intersection. So I'm going to get the point of intersection of AB and the line N, and that will equal the point B. So n we said was 2x plus 3y minus 51 equals 0. And we've just found the line there, AB, the perpendicular line. And that we said was 3x minus 2y plus 8 equals 0. So I'm going to call them equation 1 and 2, and then we're going to do simultaneous equation to find the point of intersection. So in other words, we have 2x plus 3y equals 51, 3x minus 2y equals minus 8. I'm going to multiply the top line by 2 and the bottom line by 3 to eliminate y. So we have 2 by 2x is 4x, 2 by 3 is 6y, and 2 by 51 is 102. And then we have 3 by 3x is 9x, by 2y is minus 6y, and times 8 is minus 24. 6y minus 6y is 0. And then we have 4x plus 9x is 13x, and 102 minus 24 is 78. Therefore, dividing both sides by 13 gives me x is equal to 6. But of course, we need the coordinates of b, so that means I have to find y. So always making sure you go back and find the y value. So I'm going to sub x into 1. Again, it doesn't matter whether we sub it into 1 or 2. We should still get the same value. So we have 2 times 6 plus 3y equals 51. Therefore, 51 minus 12 is equal to 39. And therefore y, if I divide across both sides by 3, is equal to 13. So what that means then is the coordinates for b is equal to 6, 13. There was 10 marks going for that, which was broken down into 0, 3, 5, 8, 10. Sorry, that should be a D, not a C, obviously. So the marks broken down into 4 parts. Okay, and then we had C. So there's only 5 marks left, which is going for this part of the question. And if you ask me, I'd imagine originally this was worth 10 marks, and A was probably worth the 5 marks, and then it was probably poorly answered in the leaving cert, so the marks obviously were changed in the marking scheme. Because there's a lot of work that goes into this question here for just 5 marks. So we have 2 touching circles, S and T, and they're shown in the diagram. We're told M and N are 2 lines from the very start of the question, are tangents at A, and at N, the tangent is the point B. And the ratio of the radius of S to the radius of T is 1:3. So in other words, if I draw a line all the way, then we know that the centres, if I mark them in blue, the point of contact and the centre of B, A and B, they all will be collinear. In other words, they all lie on the same line. Now we're given this information here that the ratio of the radius of S to the radius of T is 1:3. So if I was to draw that, what they're saying is R1 is to R2 is in the ratio of 1:3. But of course, if I was to look at the diameter, we could say the same thing. Because obviously your radius is just twice, or sorry, your diameter is twice the radius. So therefore the diameter 1 to diameter 2 would have to be in the same radius as well, 1:3. Okay, so if I know what A is, A we said was -2, 1. We've just found B, which was 6, 13. Now, if you have gotten B wrong from the previous part of the question, but carry on the rest of this question the correct way with the wrong value, you should still get your full marks at the end, as long as you don't make a further mistake. So what we can see is this point of contact between the 2 circles will be the internal divisor. So in other words, the point of contact of the circles S and T is equal to the internal divisor of AB. So again, if we go to page 18 in our maths tables, we get our internal divisor is xy is equal to b times x1 plus a times x2 over b plus a. And then we have b times y1 plus a times y2 over b plus a. And now all we have to do is sub in our values. So in other words, if we're looking at the coordinates here, we have x1, y1, x2, y2, and therefore the ratio 1 must be A and B is 3. So subbing in, this will allow me to find that point of contact on S. And if I know the point of contact on S, then I will be able to work out what the centre of the circle S is and also the radius. And then I'll be able to find the equation of S, which is what we're looking for in this question. So let's sub in. We have B, which is 3 times x1 minus 2, plus 1 times x2, which is 6, over b plus a, so 3 plus 1. And then we have b, which is 3 times y1, plus 1 times y2, which is 13, over b plus a, which is 3 plus 1. And then if we simplify, we have minus 6 plus 6, which is 0, so 0 divided by anything is 0. And then we have 3 plus 13 is 16, and 16 divided by 4 is 4. So therefore that point of contact that we've just found, let me mark it here in purple on the diagram, is that point there. Right, so that's the point that we have just found. So now we need to work out what is the centre and the radius of this circle S. So let's draw the circle S and mark in what do we know. So we know A is an end point of the diameter of the circle S. That internal divisor we've just found is the point 0, 4. So I need to find C and I need to find the radius. So obviously the centre of the circle is just the midpoint. And to find the midpoint, we go to page 18 in our maths tables, and we know it's x1 plus x2 over 2, y1 plus y2 over 2. So in other words, the centre of the circle, I call that x1, y1, x2, y2. So we have minus 2 plus 0 over 2, 1 plus 4 over 2 gives me a centre of minus 1, 5 over 2. And now the radius, well, you can either get the diameter and half it or get the radius. So I'm going to get the radius using my centre point, minus 1, 5, 2, and using my end point A, which is minus 2, 1. And to get the radius, obviously, we're going to get the distance between these 2 points. So the distance will equal the radius. And my distance formula, page 18 of my maths tables, is x2 minus x1 squared plus y2 minus y1. Oh, that should be a y1. Squared. Okay. So therefore the radius is x2 minus 2 minus minus 1 squared, y2 is 1 minus y1 to be squared. So we have minus 1 squared plus 1 minus 5 over 2 is, minus 3 over 2 squared. So if I sub that in, I end up with the square root of 13 over 2 as my radius. So now I have the radius and I have the centre. All I have to do is use my equation of the circle. And we can see obviously that the equation of the circle can be found on page 19. So we're going to go with x squared, x minus h to be squared plus y minus k squared equals r squared. And obviously you have your midpoint there as well, and your internal divisor, and your distance formula on page 18. Okay, so subbing in the equation of the circle, x minus h squared plus y minus k squared equals r squared. And our centre, hk, we said was minus 1. And k was 5 over 2. And that's going to equal the radius squared. So if I just tidy that up, that's x plus 1 squared plus y minus 5 over 2 squared is equal to 13 over 4. So as I said, a fair bit of work there for 5 marks. But again, you can't tell from year to year how much marks is going to go for something. So just because it was 5 marks in 2018, it could be 10 marks another year.